we'll study refraction through a glass slab. That is, what happens to light when it passes through a glass slab. What is a glass slab? Glass slab is a substance made of glass having three dimensions and is like a cuboid shape. So here you can see the image of a glass slab. It is a cuboid shape and rectangular in its sides are rectangular in shape. Now, children, in case of a glass slab, there are two refractions. First, light travels from air to glass, that is, from rarer medium to denser medium. So, bends towards the normal. This is the first refraction that takes place. After traveling in the glass slab, the ray of light travels from glass to air. That means when light enters from air to glass slab, it is traveling from glass to air. It is traveling from denser medium to rarer medium, so it bends away from the normal. This is the second refracted ray and is called the emergent ray. Now, combining the two refractions, the refraction of light through a glass slab can be represented as this. So, over here, you can see that this is the incident ray. Now, here we have the normal, and this angle I is the angle of incidence. That is the angle between the normal and the incident ray. Now, when light is falling obliquely on the glass slab, it is traveling from air to glass. So, obviously from rarer to denser medium, so it bends towards normal. Now, here this R is the angle of refraction. Then it falls on the second surface of the glass slab at this point, and here when we draw the normal, this is an angle of incidence for this surface, and let's say we represent it by R2 and let this be R1. Now light is coming out of the glass slab, that means it is traveling from glass to air, or I can say from denser to rarer medium. Then it is bending away from the normal. So this is what is the emergent ray. Now here we have incident ray, refracted ray, and then finally when the light comes back in the same medium, this is the emergent ray. This I is the angle of incidence. Here you have angle R1 and R2, which are angles of refraction, and here it is angle of emergence. Now, if you consider this, obviously R1 will be equal to R2 because this is a normal, this is a normal, and this happens to be a transversal. So R1 is equal to R2. Now, if you apply the principle of reversibility, that means when you consider this as the incident ray, then you know the light is going to trace back its path. So in this situation, what will happen? Angle I is going to be equal to angle E. So what I am saying is that you already know the principle of reversibility. So we are talking about that for the time being, we had considered this as the incident ray. It passed through and we got the emergent ray. Now, if you apply the principle of reversibility, then this I and E will be equal. This implies that the emergent ray and the incident ray are parallel to each other. So, I can say that incident ray is parallel to emergent ray. Now here again the diagram is here, but what I wanted you to observe is that fine, this is angle of incidence. Here you have angle of refraction. This will also be R. Now children, had this glass slab not been there, then the path taken by the incident ray would have been this, isn't it? Now, when light entered from rarer to denser medium, it had bent towards the normal. And when it came back again in the same medium, that is air, it had bended away from the normal. Now you can observe that this emergent ray and the incident ray we have already seen are parallel to each other. So the light has shifted from its original path. The direction of the light remains the same, but it has shifted from its original path. So when you talk of the perpendicular distance between the incident ray and the emergent ray, then this is known as lateral displacement, or you can say this is the lateral shift. So lateral shift is now defined as the perpendicular distance between the incident and emergent rays when light is incident obliquely on a refracting slab with parallel faces. Now this lateral shift will depend upon certain factors. So let's see what are the factors on which the lateral shift depends. So here you have the first factor as it is directly proportional to thickness of the glass slab. So mathematically D, here D stands for the lateral displacement or lateral shift is directly proportional to T. What is T? The thickness of the glass slab. So more is the thickness of the glass slab, more will be the lateral displacement. Second, it is directly proportional to the incident angle. That means the lateral displacement is directly proportional to the angle of incidence. More is the angle of incidence, more is the displacement. Thirdly, it is directly proportional to refractive index of the glass. Again, there is a direct proportionality. That means more is the refractive index, more is the lateral displacement. Lastly, it is dependent on the wavelength of incident light. Now, here we have D is inversely proportional to wavelength. What does this mean? More is the wavelength, less is the lateral displacement. So now, children, you have seen what is the path of the light when it falls obliquely on a glass slab, and you finally know that the incident ray and emergent ray are parallel to each other. There will be angle of incidence will be equal to angle of emergence, and the lateral displacement is dependent on thickness of the glass slab, incident angle, refractive index of glass slab, and wavelength of incidence.